Exploratory data analysis, popularly known as EDA, is the process of using descriptive statistics to spot outliers, identify missing data, and apply imputation techniques to fill gaps in your data set. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master the Microsoft Power BI tool over the next 100 days. And today is day 51. We've been learning consistently and way past half day of 100 days. And we're actually on the course, and today we'll be studying the final chapter of the course of our exploratory data analysis that we have been learning all about over the last 4 live streams. So on the final chapter, so we are going to learn how to use Power BI, how Power BI can help us discover the relationship between variables, both categorical variables and continuous variables, by using statistical measures and box plots and scatter plots. So on the final chapter today, which is all about learning the relationship between two or more continuous variables, we're going to dive deeper into using scatter plots to analyze the relationship between two continuous variables and calculate the correlation coefficients. So welcome back to the channel. So also all data set exercise files and Power BI files that we have been using or will continue to be using over the next couple of 100 days is already linked under the YouTube description. Do make sure to download those files and practice along with me. If you're looking to start actually from day one, you can actually go to the live stream tab on the channel where you can join me from day one all the way to day 100 on the channel. So welcome back to the channel. So without further ado, let's jump back to learning and welcome to day 51. So we're actually using the DataCamp platform. You can see we actually just have 1 hour left to complete and finalize our exploratory data analysis knowledge in Power BI. If I go under the career track real quick, just to show you what we're actually doing so far. Can you see we're on the career track, data analysis in Power BI, on our 68% throughout the whole learning journey. And when I actually started this fun way of learning, I actually started with the data analysis in SQL career track, which also went for a period of 100 days. And definitely when we finish this data analysis in Power BI career track, and actually I'm still practicing my SQL knowledge, still getting my hands dirty and mastering my SQL queries with a lot of practice. So after the Power BI, data analysis in Power BI, and definitely we are moving to the next one on the list, which is the data analyst with Python career track, which is going to run for another couple of 100 days. So you definitely want to subscribe right now and put on that notification bell so you'll be the first to know whenever I go live or drop a new content on the channel so you can learn and upskill yourself as a data professional. If I click on data analytics in Power BI real quick, you see we have 17 courses estimated for 48 hours of learning, and we've covered quite a lot of learning from introduction to Power BI all the way to exploratory data analysis Power BI. Actually, this a couple of case study, 2 case studies so far. Case study 1, analyzing customer churn in Power BI, all are available on the channel. And our case study 2 was this HR analytics in Power BI. Sorry about that, which we are still going to practice and make different videos for each case study. And I think the next case study is this trend analysis in Power BI, which I look forward to before we actually move and complete the rest of the course. So let's continue from where we stopped yesterday. Actually, before we go to the first chapter, which is this chapter on relationship between two continuous variables, we have a chapter. I was stuck in this last challenge yesterday, which I've actually done off live stream. I'll just show you what the solution looks like. Let me just launch my Power BI really quick. So on the last challenge, on day 50, we're just trying to create a box plot. I'll just quickly go through the instruction and see what we've done. So what I actually want to compare, say it says creating a box plot. So comparing histogram across each category of a variable is useful, but this can be difficult to decipher actually the actual differences with the eyes only and may take up lots of space. So an alternative and sometimes more useful approach is a box and whisker plot, or simply box plots. So in this exercise, you are asked to now investigate if the career stage influences an individual's monthly salary. To do so, you create a new variable and use it in a box plot. And we've actually done that yesterday, where you actually follow the instruction of adding a new page and call it a box plot. Let me just launch that file. Mm, Let me look for it here. This should be it. Okay, let me just go to my data sets myself here to the file. So the goal was to create a box plot, box and whisker plots, and actually fill in some fields to answer the key question that we have there. That is coming up. So some few seconds. Okay, so this was the goal for yesterday. So we already created the box plots. So I'll just go through the instruction real quick. So add a new page and call it box plot. We did that. And we have to create a new column called career stage using the switch function. We did that on day 50. So the challenge was if total working years is less than or equal to 10, set the new variable as early. So if a particular employee has worked in the company for less than 10 years, so the employee is an early employee. If less than or equal to 25, that is set to mild, which is mid years of working in the company, and greater than 25, set to tenured. So we actually used a formula, a switch to function yesterday to create a new calculated column. So switch to if the total working years is less than or equal to 10 early, less than or equal to 25 mild, and greater than 25 tenured. So if none of the above is met, not available. So that's what we did yesterday. Then we actually use this new column that we created. So we call it data mutation to visualize some data sets. Actually, what we did here was we actually used the career stage that we created in the axis category, and we were looking at the average monthly income by each career stages. So we want to see those that fall the average monthly income by by this category actually. So the second box plot was to use. Okay, let me just go back to the instruction real quick. After we've created that, so create a new box plot showing the distribution of monthly income, which is the average monthly income by career stage using the review ID as the aggregation level. So that's what we did here. We're looking at the monthly income, average monthly income by review ID and career stage. And you can see that what the early, those are fall under the early stages in a career, and these are those that fall under the mild stage, so less than 25 years of working in same company, those that have spent above 25 years of working in this particular company. So you can see that. And this other box plots here is showing us duplicate the box plots and add gender so that it compares males and females within each career stage. So I read all the charts on the page to be readable. Feel free to close the visualization fields pane to help with sizing. So we duplicated this box plot and we added a new variable which is gender. So we are looking at both male and female average monthly income by review ID and their career stages. If you notice a trend, I think the males they are more. So reading the box plot is can be pretty hard if you don't understand what all these lines are doing. But let's look at the answer, the question, the final question we need to answer. So the question was, what is the average monthly income for mid-career professionals? So we want to look at the average monthly income for the mid-career professionals. So when you look at it here, so we're going to use the mean as the average. So the box is actually showing us the mean, the first interquartile. You can see a lot of information here. The quartile, mean, median, quartile, the maximum and minimum value, and the interquartile range. So you can see these are the outliers from here to here. Are actually the outliers. So that means if we have some line above this line, they are the outliers. So reading the box plots can be very tricky. But the question says, what is the Average means so the average salary for the mid-level employees that have spent less than 25 years, more than 10 years, but less than 25 years, 5 years in the company, their mean salary is this 8,800. So let's log that in. That should be 8805, 8805. Oh, my keyboard is acting up again. 8805.01. 8805.01. So the next question now says, in which stage do female professionals tend to make more on average compared to males? We are going to go to the second box plot. So we are comparing both male and females. But we have to understand, we are going to figure out which stage the female professionals tend to make more on average than male. So one tends to make more on average salary, monthly income than male. When we look at the average here, the average there is 893216. The average there is 400. When you compare the early from the female side to the male side, you can see the average is 406. The average is 400. That means the males are making more in this in the early stage compared to the females. So let's look at the mid on the female side. This is 8932 and this is 8712. I think the females are making more here. The mid-level that have worked less than 25 years are making more. This 8932 compared to the males of 8712. Let's look at this one here. This 1500. Those are the tenured in the females compared to the males 1600. I think the answer is the mid-level here. Mid-level, the mouth or the mid. Just a minute. Oh, my keyboard is not actually connected. Well, let me just use my other keyboard here. Sometimes we feel some technical challenges. So that should be the mouse. So correct. So we knew that precisely. So that was where we got stuck on yesterday. We had to attend to an emergency. So that is correct. Average monthly income. Professionals in the middle of their career make an average monthly income of 8,800 per month within this sample. So that's the correct stage. Female professionals with 11 to 25 years of experience make slightly more per month on average than their male counterparts. So for this exercise, we have already imported the bus plot visualization for you. So that was the challenge that we were stuck at yesterday. And reading box plots can be pretty challenging. But what we want to focus on is this, or the main calculation, probably based on what you're actually looking for, and other parts of the chart. You can learn more about box plots on online, which I'm still trying to learn more about to understand how to interpret each or part of the box plot. So let's move on to the last and final chapter on the course, which is comparing relationship between two or more continuous. Let me see if I can get my actual keyboard that is my front to work fine. Because using the extreme keyboard to my left hand side to be challenging. I have no idea why my main keyboard is always having technical challenge most of the time. Definitely, I need to get a better and more secure keyboard then. I'm trying to disconnect it. Oh, I think I need to find a solution to this finally. So, but let's continue. I could just troubleshoot and make use of my extreme end keyboard. So let's learn about how to calculate relationship between two continuous variables. So instead of what we did last time, we did relationship between continuous variables and categorical variables.
Continuing the fourth step of the EDA process, we will move into exploring the relationships between two continuous variables. Scatterplots expose the relationships between two continuous variables. They are ubiquitous in data analysis and visualization. The basic elements comprise first of a continuous variable on the x-axis and another on the y-axis. Each dot in the chart area represents one observation within the dataset. The placement of the dot is related to the position of the continuous variables on the x and y axes. Here, the further to the right a dot is, the larger the total bill. The higher up on the scatterplot, the larger the tip. Returning to the previous scatterplot showing tip amount versus total bill, we would first describe the relationship between these two variables as positive, the direction. Said another way, as the total bill amount increases, so does the total tip amount. Trend lines are often helpful for making the direction of the relationship more clear. The goal of the line is to go centrally as possible through all of the points to model the data. Strength of a relationship can be determined visually by looking at how dispersed the dots in the scatterplot are. Are they tightly packed as they move positively or negative? Or is there more space, variation among them? In this graph, there appears to be some slight dispersion. Therefore, we could call the relationship moderately strong. For learning purposes, let's take a look at a couple of more scatterplots. First, we see a strong, positive relationship between two variables. The cluster of points are moving upward to the right, or as x increases, so does y. There is also very little dispersion. Next, we see a strong negative relationship between two variables. The cluster of points are moving downward to the right, or as x increases, y decreases. There is also, again, very little dispersion. Here we see a weak positive relationship. The cluster seems to generally move upwards to the right, but there is so much variation in the data points it is difficult to say. Finally, there is a large blob of data points with no real direction. This would indicate very little to no relationship. Articulating the relationship between two variables from a scatterplot is helpful, but being able to quantify this relationship can bring rigor to your analysis. The correlation coefficient is such a statistic. It ranges in value from -1 to 1, where -1 indicates a strong negative relationship, 0 indicates no relationship, and 1 a strong positive relationship. The details about the calculation are beyond the scope of this course. Returning to our example scatterplots, let's add a correlation coefficient for each. 0.9 for the strong positive relationship, minus 0.9 for the strong negative relationship, 0.35 for the weak positive relationship, and 0, of course, for no relationship. Finally, adding further context to scatterplots can help unlock the story being told by the data and the relationship. A common method to do this is through adding other variables as visual elements, color, shapes, size of dots, etc. Here we see the variable party size representing different colors, where darker colors are a smaller size of party. Intuitively, Smaller parties also have smaller bills and therefore tip amounts. Now it's your turn to build and interpret scatterplots.
Okay. I think the way is understanding the relationship between two or more variables. So strongly positive, strong negative, weak positive, no relationship at all. So practice interpreting a scatter plot. Or how would you describe the relationship of direction and strength visualized by the scatter plot? Height versus weight of 500 over 500 individuals by gender, both male and female. Hmm. You see that they are tightly packed. That's the first observation. We have a variable called male and a variable called female. So we could say the higher the weight of the individual, the higher the height. So we say it is strongly positive. So this is a strong positive relationship. Definitely strong positive. Correct. Perfect. So the data points are increasing towards the right, which indicates as height increases, so does the weight. So the data points are also more tightly clustered together or tightly packed together than dispersed, indicating a stronger relationship. That's interesting to see. So exploring any listings with scatter plots. Okay, let's give this a shot.
Hi again. I hope you're enjoying the course so far. In the last video, we explored instantly bookable listings and acceptance rates across the 4 Airbnb cities. Now, let's revisit price, a continuous variable, and its relationship to other continuous variables in the dataset. Specifically, I would like to understand how the square footage of a listing relates to its price. We can do this with scatterplots. To create one, I'll first add a new scatter chart visualization to the page, then add price to the y-axis and listing size square feet to the x-axis. It is important to remember to update the summarizations applied to these two variables, as Power BI may automatically choose some. So I'll click into the options for each one and choose Don't Summarize. Great. The scatterplot shows a moderate strong to strong positive relationship between the listing size in square feet and its price. Said another way, as the size of the listing increases per square feet, so does its price per night. How does this change by city? We can add further context to the scatterplot by dragging the city variable to the legend. We see there are a lot of colored points near the bottom left of the chart. There are also 6 points in the upper right of the chart. They are listings from Rome by the orange color. Must be some fancy houses if they are 10k a night and 30k square feet. Adding a second bar chart next to the chart adds further visual context. I'll create a new stacked bar chart, adding city to the axis and listing size square feet to values as median. The bar chart doubles as a control for a filter by city. As I click on each bar, the scatterplot will show just the data points for that city. This allows interactive exploration of the relationships between these two continuous variables. I don't want the axis ranges to change as I change cities. I'll update the formatting by clicking into the Format tab under Visualizations. First, I'll change the x-axis and set the start value to 0 and the end value to 30,000. For the y-axis, I'll again set the start value to 0 and the end value to 11,000. Power BI offers advanced analytics features which can be added to charts. For scatterplots, this includes a trend line. As discussed in the previous video, a trend line helps define a linear pattern that is as central as possible through all points. To add one, simply click into the Analytics tab. Under the Trend Line drop-down, click Add. The new trend line is a visual additive representing the relationship I mentioned previously, strong and positive. We can quantitatively describe the relationship using the correlation coefficient. Power BI again makes this simple through a quick measure. To create one, Right-click on the dataset and choose New Quick Measure. In the pop-up window, under Calculation, select Correlation Coefficient. Add listing ID to the category, listing size square feet to the measure X, and price to the measure Y. Clicking OK, Power BI will create a complex DAX function to calculate this metric. I'll add a card visualization to the page to showcase this new calculation. First, I'll rearrange the existing charts, and then select card and drag the new measure to fields. A correlation coefficient of 0.9 is really strong. Again, you can filter for each city using the bar chart to see how this metric changes with just the associated data points. Rome seems to have the strongest correlation. Therefore, we can predict with higher confidence that the larger the listing in square feet, the higher the price. Now it's your turn to explore the relationships of continuous variables with scatterplots and correlation coefficients.
That's great. So you can see that the higher the listing, the stronger the relationship. Okay, so let's try to solve these three challenges: analyzing relationship with scatter plots, adding context to scatter plots, correlation coefficients, and okay, we have three challenges to solve here. So analyzing relationship with scatter plots. So scatter plots are fantastic tools for visualizing relationship between variables. They also provide insight into the direction and potential strength of the relationship. So in this exercise, you create several scatter plots comparing monthly income to other variables. Then you will determine which variable has the strongest relationship. Okay, so let's give this a shot and see. So let's open our file, scatter plots. So on a new page named scatter plots, create a new scatter plot of years at company versus monthly income. So I want to see the relationship between probably if you spend more years at the company, is your salary increasing or are you getting promotion? So let's give that a shot. So those are cool questions to answer. Okay, interesting. So this is the solution to the last challenge. Let's create a new page and move on. I'll call it scatter. Let's call it scatter plots. So we're going to drop the scatter plots showing years at company versus monthly income. Let's look for a scatter plot. This is right here. Yeah, that's it. So we're going to drop years at company versus monthly income. So the challenge, we could just drop it on the any axis we like. But let me just use years at company first. Years at company. This is right there. Versus monthly income. Monthly income. Oh, that's it. So it is just dropped years at company. So what I need to do now is I'll put it not to summarize because it's going to summarize that for me. Let me show you. If I come here, you can see, let me just come here. Can see it's summarizing it. That's why we're having one single point. But what I don't want you to do is don't summarize. Then for the monthly income too, don't summarize. Aha. Looking well, very, very scattered. Ooh, this is a lot of data points. Let's follow the instruction. So the next one is create a new scatter plot of total working years versus monthly income. Let's duplicate this or just bring this here. Total working years Let's drop in another one. And we call this total working years. So same monthly income, right? Total working years versus monthly income again. Monthly income again. So which is already summarized. I'll just click on it and say don't summarize. Don't summarize. Ooh, this is looking rough and actually well scattered. Let's see, create a new scatter plot of job level versus monthly income again. Okay, but I'm more curious whether I place it correctly in the right value. Let me just quickly watch thing really quick. The right field rather.
feet and
Exactly. So I place this in the right field, both x-axis and the y-axis.
its price. Said another way, adding a second median.
Let's see.
The bar chart
You can see, okay, this was this one. So we place it correctly in the x-axis and y-axis value. So let's go on and create a new scatter plot of versus job level versus monthly income. Let's create job level versus monthly income. Just make this a little bit smaller here. So we're going to call this job level. Let's see a new one. This is going to be job level. Let's add job monthly income. Let me just add the job level first. Job level versus monthly income. Monthly income. So don't summarize also. Don't summarize. And this also don't summarize. Okay. Now let's create more space for them. Okay, I think it is not making sense right now. Okay, so moving on to the next instruction. So it's create a new scatter plot of number companies worked versus monthly income. Ooh, this is a lot of scatter plots, eh? Let's drop this. Yeah, so these are the two first one. I'll just bring this right here. So I'll have more space for my final scatter plots. So one more scatter plot to add. This time around, we're actually looking at number of companies worked versus monthly income. So I compare monthly income over and over again. Numbers of company worked. What is that variable? Num companies. Okay. Number of companies work versus monthly income. Monthly income. So our summarization should be set to don't summarize. So you can have a good data point there. Don't summarize. Okay. Ooh. I've used two different pages for this so you can see it clearly. Let me just grab these two. Let me create a new page. Or what I could just do is I could just duplicate the page. Duplicate. What I want to do, I want to get rid of this two down here. Just remove this two down here. So I have more space for this, so you can actually see what's happening with the data points here. So this one is total working years versus monthly income. Years are company versus monthly income. So those are the two first one, right? So this is the first one. The first one is years are company versus monthly income. Total working years versus monthly income. While the second one is going to be, let me just get rid of this right here. So you could see this data point clearly now. Okay, now let's see how we can interpret this, because these are just not making sense. When you just firstly look at it, it looks way too odd. Now let's go to the instruction. It now says, which variable has the strongest positive relationship with monthly income? Is it job level, years of company, total working years, or number of companies worked? So let's look at it. With monthly income, has the what? Strongest positive relationship. We look at years of company. If you mainly looking at it, I think there's lots of congestion down right here. It's slightly packed here, but so the higher the years are company, the higher the monthly income, because it is not actually moving to the right hand side, it is moving to the left hand side. When we look at this total working years, I think it has more strong relationship with the monthly income. But don't let us, if I should go for total working years, let's say, hold a minute. Let's assume we look at this. This is pretty odd. Way odd. Oh, job level, monthly income. So if I want to look at the correlation for that, that was one of the easiest way to actually look at that really quick. So I'm either going for years, total working years, or job level, which is same challenge. Let's log that in first. Oh, I failed it. Now, if my second option is job level, that's my own personal second option, but I may be wrong. So if total working years isn't the total working years, mm, it's definitely not years at company. I said it. So is that either job level or total working years? Perfect. So the senior professionals make the most monthly income. So it is either one of the two. So I should have guessed right. I should have not even guessing. It's actually showing here, you can see. So the higher, you can see that it's moved way more to the right hand side, and they're actually more packed compared to uh the year total working years here. Oh, I should have gone for that. I should have gone for job level immediately, because the job level is slightly more packed with monthly income compared to the total working years, which is more dispersed, slightly more dispersed. Okay, but we got that. So that was the so we knew that. So let's move on to the next challenge of adding context to scatter plots. So basic scatter plots can tell a lot about the relationship between two variables. Adding other continuous or categorical variables, visual element can provide further context. So in this exercise, we will dive deeper into the relationship of job level and monthly income by adding more context. We want to focus more on the job level versus monthly income. Okay. So on a new page called scatter plot color, copy the previous exercise scatter plot showing monthly income versus job level. So I'll just duplicate this real quick. Let's duplicate this. Okay. Let's call it scatter plot 2. Then we've called it scatter plot 2. I'll just duplicate this. Duplicate. So we're going to call it monthly income scatter plots with color. I'm going to get rid of this. So I have to focus on job level versus monthly income. So let's focus on this. So if you add more context to it, probably want to look at it by males, by gender rather, or female. So add a color to the story of the scatter plot using by adding job role to the legend. Okay, place the legend on the bottom of the chart. So let's look at the legend. It says add a color to the story of the scatter plot by adding job role to the legend. Okay, let's add job role to the legends of this chart. To the legend, let's add job role. This job role here. So you could see those that are earning more. Okay. Oh, this is tightly packed. I think this color here, who are these here? The managers. Oh, definitely the managers. I think the managers are more packed at the upper end here. So you can see we have some managers also right here. Okay, research director. We have some mostly research director here. Why this sales? So let's move on to the next question. So format the scatter plot to maintain a consistent x-axis and y-axis. In order to do this, make a change on the ranges. So let's maintain a consistent x-axis and y-axis. So we just start from 0 to 5. Okay. This is the format that we could just use the format pane here. If you go to the x-axis, so we could set the minimum. So it's setting to automatic. We want to use the minimum range and maximum range. Okay, so the minimum should be, I think the minimum should be 0. Yeah, the minimum for the x-axis. So let's leave it at 1. 0 is bad. Let's leave it at 1. And the maximum should be 5. We have 5 levels of job role. We want to maintain it. Y for the y-axis, the minimum should be 0. And the maximum should be, what's the maximum there? Okay, hold up. The range, nope. The range from, for me is 0k to 5k. What's the maximum here? It's 20k. No, just 20k. Uh-oh. I've distorted my scatter plots. Let me just get rid of it one more time. Come back here. Control C. Control V. Let me just copy this. So let's try again one more time. So the axis, hold on. Let me just format the axis first. The y-axis, is it the values? Not under the values. Is the range. Minimum is 0k to 20k. 0, 20, 1, 2, 3. Okay, so we're about to 20K, not 20. I was using the wrong value there. That's for the y-axis. By the x-axis, the minimum is 1 and the maximum is still 5. So we've given a consistent axis. So I could just add the legend. So what are we supposed to add on the legend? The job role. No, the job level rather. The job level. Nope. 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 Add the job role rather. Yeah, the job role. Job role. So yeah, so the job role. I have given it consistent uh formatting. So now let's move to the next instruction that says create a scatter bar chart showing the count of reviews by job role. Create a scattered bar chart, a stack bar chart rather. Let's bring this rightly here. I'm going to add a new chart, scatter. You have to insert a stacked bar chart rather, stacked bar charts. Oh, I'm not using 100% stacked. Use stacked. Why is stacked bar charts? Okay, this is a stacked bar charts showing what only does believe is showing. Showing count of reviews by job role. Showing the count of reviews by job role. Okay, job role review, which is going to be the count by job role. Job role. Okay, you can see. So you can see this is the count of reviews by job role. So you can see the research scientist has more reviews compared. So let's move on. So finally, create two card visualization, one for the median monthly income and the other for the average monthly income. Arrange the cards at the top of the page and the cards and the chart at the bottom. So I want to create two new cards. So let's give this more space. So our card is going to be showing. Let's bring this a little bit further. So for the cards visual, it should be showing median monthly income and average monthly income. So that's pretty easy. So card visual. So the first card visual will be showing median monthly income. Let us just give it enough space here. Let's see what we are trying to achieve. So we're going to drop in monthly income on the card visual. Monthly income. So for the monthly income calculation, it's going to be median monthly income. This is the median monthly income. I could just duplicate this card. Ctrl C, Ctrl V. The first is median. The second is average monthly income. So this is the average monthly income that we have. Then arrange the card at the top to be at the top of the page and the charts on the bottom. We've done that. Using the bar charts to filter the other visualization by job role, explore the relationship between job level and monthly income. Changes for each separately. Using the bar charts to filter other visualization by job role. Explore the relationship between job level. Using the bar charts, okay, to filter the other visualization by job role. Explore the relationship between job level and monthly income. Let's look at the research scientists. See the relationship. Look at laboratory tech. See the their median monthly income, their average monthly income, and their relationship between job level and monthly income, and so on. Okay, interesting. Now, what question are we to answer right here? It says, which job role has the highest median monthly income? I'm definitely sure it's a research scientist. You can see the median is 2,800 for research scientists. The median for laboratory tech is 2,700. The median for sales executive is 6,300. You can see. So definitely. Ooh, look at healthcare. Health representative. They have the highest median. Oh. Look at research scientists, just 2,000. While health representative has 8,000. Ooh. What about managers? 17K. Research director 16K. And human resources, definitely the managers. Oh, definitely the manager. Okay, let's lock in the manager. That should be the managers. Correct. Impressive. Managers make more money on a monthly basis than other type of roles. They also tend to be the higher levels. So definitely. What about the research scientists are having more review IEDs? They're being more reviewed. Probably they have less manager, which is normal, but the research scientists are having more reviews compared to other job role. Reason we don't know. You see, the job level and monthly income of managers is on the high side. The higher the job level, the higher the monthly income. Interesting. And the average monthly income is 17K. Ooh, that's interesting to see. So let's continue to the final and last challenge, correlation coefficients. So scatter plots are great a visualizing relationship between scatter plots are great for visualizing relationship between two variables or more with visual context. An analysis is even more powerful when adding a quantitative metrics, correlation coefficient, to describe the relationship as well. So in this exercise, you will use a quick measure to calculate the correlation coefficients, then interpret these metrics to derive insights, to derive an insight. So let's continue. So add a trend line to the scatter plot to show the general relationship between job level and monthly income. So let's add a trend line to this. I'll just unfilter this so we are back to the full context. So I'll just let this job level and monthly income visual. So we go to the format pane. Under references. We should have this under references. Let me just switch off my camera real quick there. We should have this under the reference line. We want to add a trend line to so we can calculate our correlation coefficients. We say add line. I'm going to select the type of line I want to add. Choose type. Uh-oh. Ooh. Oh, we have a trend line. You can see the references. Okay, this is the trend line available directly. If I put on the trend line, you can see our trend line is showing. I could just definitely format the trend line more. Okay, we've already added the trend line there. Let's see. So calculate the correlation coefficient using a new quick measure. Okay, let's calculate the correlation coefficient using a new quick measure. If I go under the data points, or I click and say new quick measure. Then for this, we could just make use of Power BI interface correlation coefficients. So I'm going to add my values. My category is going to be, what my category be? Measure X, measure Y. My category is going to be, my measure X definitely be my monthly income. Let's see monthly income. Let's look at my measures here. So my x-axis is going to be job level. Then my y-axis is going to be monthly income. Monthly income. Let's drop that in. For the category, let's see my information. The category to find the correlation over. Mm, the category is going to be on job level. Definitely job level. Okay. We can just take a peep. Let's look at what the instructor did there, just to be sure.
High
Let's see where it was calculating correlation coefficients.
category, listing size square feet to the measure x and price to the measure y. Clicking OK.
I see what he did there was adding based on the charts when it was creating the chart, they are listing the category as listing ID. Let's see.
One and choose Don't Summarize.
Listing size square feet, price, the details.
Great.
Okay.
The scatter plot shows a moderate strong to strong positive plot by dragging the city variable.
So he actually used city when he was doing his own. But let's see. Okay. But we could just create it one more time. If you are not sure, let's click on add, which is creating the measure. Okay, we have our measure here. A, a lot of codes that we have no idea what it's calculating. Okay, let's log that in. We've calculated our job level and monthly income correlation coefficient. Let's use a card to actually visualize that and see if it makes sense. It says calculate the correlation coefficient using a new quick measure. Create a new card visualization for the correlation coefficient. Arrange the cards to be evenly spaced at the top. Let's drop in a new card visual. For our new card visual, we're going to add our job level correlation coefficients. Oh, that is pretty strong correlation there. This is 0.96. That shows a pretty strong correlation coefficient. Okay. I think we know that our category is going to be on job level. Okay. So let's look at the final question there. So what is the correlation coefficient for the relationship between job level and monthly income? That is 0.96, which is pretty strong. 0.96, which is a pretty strong correlation coefficient. Ooh, I failed it. My bad. 0. We say what is the correlation coefficient for the relationship between job level and monthly income? Hmm. You can see 0.96 here. So what's now the challenge? Hmm. Probably I chose the job. Okay, I use job level rather than using job role. I think my category should be on job role, not job level. So let's do it one more time. Let's do the calculation one more time. Let's get rid of the calculation. Is there a way to format it? Let me see if I can edit it. Let me delete this my calculation from the model. So I use job role, job level rather than job role. Let's get a new quick measure there. Want to create quick measure, new measure. Why can't I find new quick measure here? Okay, let me just use quick measure here then. Let's do it one more time. Correlation coefficient. My category is going to be job role. My x-axis going to be job level. My y-axis is going to be monthly income. Let's add and see. Okay. Job level and monthly income correlation for job role. Okay. So let's drop that in on the card visual. We have 0.95 right now. Let's see if you are correct. 0.95. Yeah, we got it. So that's right. This positive correlation coefficient means both variables move in the same direction. As job level increases or decreases, so does the monthly income. So I actually used the wrong category for it. So I was supposed to use job role, not the job level. We're actually looking at job level versus monthly income. So we nailed that correctly. So that was quite interesting and a little bit of tough and challenging, but we were able to solve all that. That was so we could actually look at for each job role, we could look at the correlation coefficient. If I click on it, wow, why is there no correlation coefficient for between research scientists? That means their monthly income is not even increasing at all, which is pretty bad. Oh, oh, because it's understandable. But these are all the job roles. Oh, this is job role, but my coefficient was calculated for job level. That's why I'm not getting the result there. So interesting. So you need to understand what the variables we are looking at before actually interpret data sets. So that's all for this live stream on Scatterplot. It's here in Power BI generally and Scatterplot.
Exceptional work on this exploratory data analysis course. Throughout the course, you got familiarized with many aspects any data analyst should know when starting on a new dataset. You now know how to identify and impute missing data, how to find and address outliers, what to do with multiple categorical variables, and how to handle continuous variables. In addition, you learn best practices on visualizations for EDA, including histograms, box plots, and scatter plots. While these might look simple on paper, having a thorough understanding of these concepts will improve the overall quality of your analyses later on. There are, of course, more analytical possibilities, and you can use Power BI's capabilities to harness them. In the follow-up course, Trend Analysis in Power BI, you'll learn about time series analysis, decomposition trees, and key influences, all analytical techniques to take your reports to the next level. We hope you enjoyed taking this course and would love to see you again in the next one.
All right, so we've actually completed this course. Good job. So we're moving to the next one on day 50. Is it the 51? Day 52, actually. So we're moving to trend analysis in Power BI. So that'll be all for this live stream. And I'll see you on day 52, starting to explore time series data analysis in Power BI. All right, so thanks for staying to the end of the live stream. So if you watch to the end and you practice along with me, and are actually able to solve those questions and give insights on the data sets, thumbs up to you. You're the real MVP. All right, do not forget to support the channel by hitting that subscribe button, put on the notification bell, and let me know your thoughts under the comment section. I'll be happy to read your requests, answer your question, and reply to your comments. All right, bye for now and have a wonderful day wherever you are.